The broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's webinar entitled Holistic Design, How to Recognize Sustainable Practice from Greenwashing. My name is Billy Zadig, Manager Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later today. This will be our final 2022 webinar. So check our website if you would like to go back in and review any of our archive webinars for continuing education credits if you need them. Professional continuing education credits are being offered for today's program. AIA members who need their attendance reported to AIA should contact me at Billie, B-I-L-L-I-E, at APA.org. Those who indicated they wanted a certificate at registration and meet the requirements will receive their certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. If you're just calling in, make sure to send me an email at billie@apa.org so I can send you a certificate if you would like one. The system will only recognize you if you log in. Before we get started today, let me tell you a little bit about our speaker. Bill Coons is a registered architect with extensive experience in the higher education, life sciences, advanced manufacturing, and corporate market sector. He has spent his career guiding clients and projects towards sustainable solutions and has over 60 sustainable projects under his belt, including interesting LEED Gold certified projects for the Krishna P. Singh Center for Nanotechnology at the University of Pennsylvania, the first 3 LEED certified semiconductor projects in the world at Global Foundries, and one of the largest and first solar panel manufacturing facilities in the United States for Tesla. In addition, his experience as a certified lighting designer further focuses his practice on environmentally sensitive solutions. In fact, a unique tidbit about Bill is he is one of just six registered architects in the world to hold the Certified Lighting Designer designation and has practiced as a lighting designer for over 20 years. At this time, it's my pleasure to turn this over to William Coons. Bill, take it away.
Yeah, thanks, Billy. So good afternoon, everyone, and thanks for taking the time out of your busy day to meet with us. So today we're going to really delve in a little bit into sustainability and what really it means. We talk a lot about this sustainability as a term, and we have a basic understanding, but what's happened over time is there's been a lot of superficial and additional items that are thrown out at us that kind of muddy the waters. So I always like to come back to this chart and, just talking about the strategy of what sustainability is. So you want to minimize your environmental footprint, operational excellence. So really take the time to look at how we operate our buildings and our spaces in a sustainable manner. We want to really foster a culture that's learning and understanding and always striving for a better understanding of what sustainability is, and obviously ensuring a healthy, sustainable workforce. So really keeping people engaged and looking at the future. Climate change, no matter what your opinion is about climate change, one of the things that we can all agree on is that the need for being responsible with our natural resources, no matter what they are, is super important because we only have so much of all of it. And then protecting the marine ecosystem, one of the many things that we see, and we've all, especially if we live anywhere near a coast, see the horrors of people that have really damaged our oceans and damaged our coastlines. So taking all of that into consideration is important. So as we move forward, I really want to talk about the history of sustainability. Most people understand it started, in the last 20 years, but realistically, it really started from the 1940s and really looking at how sustainability can be pushed into the public realm. So, one of the things I like to tie everyone to, you have to all remember in 1950, the world had a population of 2.5 billion people. And government agencies were really starting to understand that we were growing at a faster rate, and somehow we were going to have to be able to accommodate all the people that were eventually going to be on the planet. So by the 60s, we're only up to 3 billion, which isn't too bad. And there's a lot of discussion, whether it's, the first photos from the Earth, whether it's a conference that we talk about, the US established the EPA. And then by the 70s, you can see we went from 3 billion in 1960, not, 3.7 and then 4 billion in the 70s. Well, as we move forward, really what we talk about expands upon what we need. And more so, not only does the sustainability discussion expand, but the growth of our population really pushes the envelope. So, if you look at 1950, we're at 2.5 billion, and in 2020, we're all the way up to 7.8 billion. So, we really need to consider how this is affecting not only life on the planet, but also how we approach our well-being. So, in the early 80s, there were a whole number that started of ways that we can really look at and measure sustainability. BREEAM was the first and was really the precursor for LEED and subsequently Green Globes. We also have WELL now, which was a fold out from really the USGBC and LEED, and then National Green Building Standard, which many states are now adopting. So we've got green building requirements that exist as part of the code. Passive House has both taken on not only a residential aspect, but some of those aspects are being pushed into commercial development. And then ASHRAE 90.1, really this basis of our energy code and how we push that envelope and how sustainable we need to be. So, some of the questions I like to ask everyone, and, today's no different. What are some of the benefits of different fossil fuel sources at our disposal? Is anyone better than the other? Are we at a crossroads in energy usage? And where do we go? And can we name the top 5 sources of energy usage today? And how about 1980? So if we look at historic fuel consumption, and really when we talk about energy, this is where it all starts, right? How we use our energy and what we use it for. So here on the left, and this is from U.S. Energy and Administration and the AEO 2021. So if you look at how we produce energy and where we use it, you can see that over 42% of electric power is where we get most of our energy. Industrial transportation uses anywhere between 25 and 30, and residential and commercial we're using much less, 0 to 5%. When we talk about overall energy consumption. But when we talk about energy consumption by fuel, you can see that we have a number of different sources that are all being used. Despite all the discussion in the industry, petroleum and other liquids, natural gas, are all being used at a higher rate than anything else, and that growth is continuing. You see our renewable energies in the 90s were around 5% and are now at about 17, 18%. Nuclear has stayed pretty flat, and we'll discuss that a little bit, and coal has seen a significant drop off. And then hydro and other biofuels are out there too. So let's talk a little bit about some of the advantages of each. So you can see here that while fossil fuels are our primary source, they have some significant advantages and significant disadvantages. They still are the most readily available. The energy per use or per quantity is much higher than any other source. And it's available, it's stable, and it's currently abundant. And the big advantage to that is that our energy needs are so great that unless we make a significant change in a footprint, it's very hard to remove ourselves from the fossil fuel world unless we can find something that can replace it with these advantages and hopefully remove some of the disadvantages. So renewables, relatively speaking, is a permanent source. We like to believe there's no greenhouse gas emissions during use, and there's potential for future improvement. The downsides to them is they're electricity only. They're low in efficiency. So solar, for example, is 17 to 23% efficient. So that means for every kilowatt, you need to put in 4 times what you would need if you were using a fossil-based or other source. Manufacturing is highly energy intensive. There are a lot of heavy metals used, and there can be numerous environmental disturbances. Hydroelectric reroutes, rivers and lakes. If we look at what's currently happening in the Pacific Southwest, and look at Hoover Dam and look at the dams along the Colorado River, there's significant concern there because the water usage is being pushed in different directions, making hydro less and less viable. Fusion, a great source from a energy per quantity. Again, it's a electricity only, so there's some advantages to that if we move to a more electric-based society. But it has some perceived waste that is a large concern. So it is also expensive to build a plant, and obviously the public has come out of fusion and said, well, we have a real problem here. We don't want this in our backyard. It's dangerous. We're concerned about destruction of plants and what that would do. And then something that's really not a source, but more of a way of how we can all help on a daily basis is through conservation. And whether we're recycling or using alternate means of transportation, using setback thermostats, improving the insulation in our homes, all of those things can improve the air quality, improve soil erosion, stabilize the environment. But there's an impact to us, right? And we need to be well educated to understand what's going to help and what isn't. So something that we look at when we look at overall fuel costs, and this is gasoline, and I know we've all gone through in the last couple of years some really drastic hikes in gasoline prices. And some of the decisions that have been made, not only in the US government, but globally, have impacted this. So if we look at 1978, and this is a gas price per year and then adjusted for inflation, and so this is all based on 2020 dollars, we essentially have a flat cost for gas. We don't see it that way, but it is something that is readily apparent as we look at overall prices. So even when we have spikes upwards of $4, $5 a gallon, we're not addressing some of the California issues where they're up in the $7 range, but we still stay pretty flat. I think the spikes of the last year probably push us more into the $3 a gallon inflation-wise, but still something for us to consider. So, and in addition, I mentioned earlier that solar really has a positive and a negative discussion. From a installation on standpoint, You set a panel up on your roof, it works, it goes along and produces energy, and for the most part gives you most of what you need, because the solar installers are planning for the inefficiency that are in the panels. The downside to it is the cost. It is a semiconductor-based product, and as such, it has some fairly significant environmental impacts during the manufacture. So we have to consider that when we plan on installing solar panels throughout, the industry, because that impact is an issue. When we get to the end of their useful life, which is about 20 to 25 years currently, there's some waste there that can't really be left and ends up in a landfill. Now, on the plus side, if we look at 1977, to produce a kilowatt of energy costs us about $76.67 a watt. And as you can see, by 2021, we're down to 70 cents a watt. We still have a cost on installation, but the cost of producing energy via solar has come down significantly. The next real improvement in this sector is really getting to a change in thought process on how we manufacture and transmit solar energy into electric. So, nuclear fission. I think nuclear fission is one of those things that we talk a lot about, depending on what shape the government takes at any given time. It is demonized, it is considered unusable, but one of the things we need to really think about is nuclear power produces 790 billion kilowatt hours of electricity as of 1990. That was the first time in 2020 that it passed coal. So now we're transitioning to a different form of power. Provides 52% of our clean electricity. So despite the fact that we have this misnomer of what really nuclear energy can do, we're using it significantly, despite the fact that we don't understand that. 92% energy efficiency at full capacity. So it's producing more energy than anything else from an efficiency standpoint. Natural gas, which is the best of the fossil fuels, is only a little over 57%. So the other thing to think about is there's 94 commercial reactors in 28 states, and it helps produce electricity at that efficiency for 28 states in the US. One of the things that always comes out of the discussion of nuclear energy, and that is the waste, right? So all the nuclear fuel used in the US since the 60s would fit on a football field less than 30 feet deep. That is far less than the impact of any other source that we have in current use. So let's translate this into building materials and how we look at what we use. One of the things that we all need to remember is the top 10 building materials haven't changed in over 100 years. We're still using the same things to build our buildings that we used when our grandparents were alive and our great-grandparents. So, how do we use them differently to present a more holistic design for the environment? That's the key. And the key is all about education. So how do we learn to use materials in a more sustainable way? And what can we do to improve the built environment? So top 10 building materials. This is, as we said, 100 years plus. Steel, concrete, wood. For those of us that do a lot of work in the higher education world, stone, brick, masonry, glass, aluminum, those are all primary materials as we look at the exterior of our building. So as we look at this, we really have to consider embodied energy. And that's really the driving factor for how we make correct decisions in, in making decisions on products and materials to use. So if we start at the beginning and we use the design process and the production process of the material, combining those together, getting it transported to the site, using it, then disposing of it at the end of its useful life. So really important here, you could have a product that has a little bit more energy intensive manufacturing if it lasts a lot longer. If I'm having to replace a product every 5 years, it's probably not, its embodied energy isn't really as realistic or good to use overall. But we have to balance that, right? So as we look at the next slide, what you can see is this is a comparison on just insulation. Okay, these are all the insulations that we look at in the world today. And what I want you to notice here is the thickness. To get the same R value for your wall, you have straw bales, which have a very low embodied energy, but you need a lot of it to insulate your walls. So as we rise and fall through here, you have to find that balance between the two. So if you look at, for example, cellulose fibers, which has an embodied energy of 19, and you look over on the right and say the thickness, it's a little higher, but it's a little further down from some of the others. So the polyurethane foam, 130, really high embodied energy. So, but low thickness. So, you know, those are all things as we examine materials that it's important for the end user to understand this balance, because the decisions that you make, if you come out and say you want a sustainable project, this all comes into play. Do we use wood versus metal? Do we use brick? Do we use stone? Where do we get the stone from? All decisions that you have to make, because as we discussed earlier, transportation is a huge part in how we get materials to site. So let's translate this to how it works for the university environment. I think one of the major things we have to consider is this is a holistic project. We have to start from land use. So as most universities have a campus that they work on, or they're expanding to remote campuses, especially with the post-COVID world, and students coming back to university sites in varying amounts, a lot more online classes, a lot less large lectures. We have to look at what's the best use of land. And then the next step is I encourage every client to reach out to design professionals and talk about master planning their site. Something that's passionate to all of us on this call is not only the best use of land, but then a logical plan that leads us forward. So we have a map, so we can make informed decisions, so we can plan for a budget. All super important to help maintain good financial decisions. Embodied energy material use is also super important, because there you're making the decisions at that point on how and what material we use. And what's its impact? Are we being good stewards? Or are we using materials to one degree or another that are wasteful? And really, as we look at some of the other factors, creative resource use, you know, we don't always have to use glass in its normal state, whether we're highly insulated glass, whether we're using glass that will help daylight penetrate the site and the building, and help us cut down on our electric use. Brick, probably one of the most sustainable materials on the planet, because you put it there and it lasts for the next 50 years as long as it's installed correctly. So again, materials are one of those things that become a really important discussion. We need to talk about the environmental factors. What's the impact of renovating a building versus building a new building? Is it even feasible to renovate? As we know, some of our older buildings have real significant problems, and the cost, unless they're historically pertinent, it becomes a lot easier for us to tear them down and build something new. But that's got an environmental impact too. So we talk about daylight. On a normal cloudy day, you get 10,000 foot candles coming from the exterior of the site through your windows on the north side of the building. So we can live with just daylight in our buildings if we can learn to get the daylight as far into our buildings as possible. That really changes something drastically within our space. Our electric lights do not need to be on all the time. They do not need to have high impacts to everything. But what they do need to do is they need to be there for those days when it's not as feasible. Safety and security. One of the things we talk about, especially on a campus, is at night, people walking around and the potential security issues that can come. So we want to make everyone safe. We want to have good open environments, and we want to make sure that not only is a campus a good place for co-eds to gather and professors, but also they can feel safe in their environment. And obviously we have aesthetic decisions, right? So those decisions really come from the fact that what's our overall campus aesthetic? What does it all look like? Do we want our new facility or our campus to stand out, or are we blending in with the environment around it? And I'm going to show you in a minute a couple of examples that really address just that. And then lastly, budgetary concerns. Obviously, we all work on a budget, and that budget is one that everyone has to be concerned about. No client, no design professional has an unlimited budget to work with. So what we need to do is establish that budget early on and then work within it to get us something that addresses all the previous issues. So next, I want to touch quickly on a couple of options. So these are a couple of projects that I've done over the years, and universities that we really addressed a number of different things on each of these that the client was interested in from a sustainable standpoint. The first is Masry Center for the Arts. It's from 2008. And this building, one of the major features to this is it is heated and cooled with a geothermal heat pump. This was a new building, ground up. It's in inner city within a major municipality in upstate New York. And it was the real desire from the campuses. They're good stewards to the neighbors, and they wanted to make sure that the building didn't really stand out from the rest. So the street front looks very similar to a lot of the Victorian homes that traditionally lined this particular street. But as we came back, it took on more of a modern feel. The heat pumps we put in the back parking lot, and it heats and cools this building year round. It cost the university somewhere in the vicinity over the first couple of years, close to $500 a year to heat and cool the entire 50,000 square foot building. We used a lot of recycled content. As we said, it was an infill site. So there are a lot of functionality here that, whether it be things like bike racks and access to public transportation, or good plantings to help reinvigorate a fauna in the area that, as a normal city area, there's not as much plantings to help reinvigorate oxygen use. Daylight. As you can see in this image, there are a lot of windows on this building, and it was all intentional to help push daylight into the building, help push natural light so that it was more equal throughout the whole day and gave us the ability to dim or even turn off the artificial lights throughout the space and let the users work in a natural environment. And then low LPD. So LPD, throwing out one of my lighting geek terms, this means we have low power for the overall building. In this case, this project was well under code, about half of what the code allowance is for electric lights. So lastly, I want to talk about another project, and this is another project I was involved in, again, on another university campus. Efficient use of energy by pushing it to the central plant. So this particular campus, we had access to the central plant without too much difficulty. And whenever we can heat and cool from a central location, you've got some more efficiency. Highly recycled content, from the exterior metal panel to the glazing to the materials inside, even to the concrete that we use to build the building. Again, another infill site. Now, it's not to say that city infill sites are the way to go. There's advantages to them and there's disadvantages to them. In this particular case, it was a very tight site, and it stood out, as this building does, as a very different building than the rest of the campus because it anchored the end of campus. And so that was one of the desires of the client, to really have a feature building on that side of campus. Daylight, again, real important. 60% of all spaces have daylight, and that's including this building, which had a number of clean rooms because this is a nanotechnology campus or school. And then efficient landscape design, again, coming back to bringing the environment back to the inner city. How do we improve that? How do we get people comfortable that they have an environment that is natural for them in a densely packed urban world? So I like to always offer some time up for questions for everybody, but I'd like to thank you all for taking the time to chat with me about this today, because one of the things that I think is super important is this is all of our responsibility. We all have to address this, and the best way for us to do it is to walk through how education and how we use our materials. Not one of us can do this. It has to be done by all of us. So I'd like to open this up for questions. I am one that is really big about communication and about discussion.
Okay, Bill. Well, we have a few questions here, and as people
Great.
think about something, we'll get started with the ones that we have. So
Great.
our first question is, what is your take on wind power as a renewable, especially in mountainous areas that have continuous windy weather?
Yeah, great question. As many of you can see, I live in Raleigh right now, and I've spent a lot of time throughout the country, and I think wind power is one of those options that are super useful when we have the ability to do it. Now, whether it's mountainous regions or let's take, for example, the plains of Western Texas, where we have very large wind farms. Really, a wind turbine is no different than any other turbine and how we produce electricity. We just stick it up in high and put some blades on it and let the wind turn it. So I think it's gotten somewhat of a bad rap in the sense that a number of environmental groups have come out against wind turbines because they are going to kill birds or because they dirty up the environment and they're not very attractive to look at. But what is? We have buildings all over the world and birds don't fly into them. We have many different types of energy, and they all have their place, and we have to get used to that if we want to continue to live the type of life we have. I think one of the most important things we need to consider here is that diversifying our energy usage is super important. So anything we can use that has a benefit and can minimize the downsides is a great option. And wind is definitely one of those issues and one of those sources.
Okay, and this is more of a comment than a question. It says renewables also include biogas, not just electricity only, such as liquid fuels from plant materials. The challenge is in cost-effective manufacturing. Do you agree?
Yeah, I would agree. And, while biomass is a definite option, one of the challenges for it has been exactly what you mentioned in your comment. You can't have a good biomass except for because of the cost of manufacturing. So as we look at these different sources, we really need to examine what the cost benefit analysis is. Whenever I talk to any client, it's about ROI, right? That's all what everyone wants to know. Not only where's my payback, where do I break even from making this decision? So biomass and a number of others that are still developing sources. We could talk about hydrogen. We could talk about a number of different things that are renewable energy, and how do we better use them? So yes, I would agree.
Okay. And just a clarification from one of our attendees, it says, do you mean nuclear fusion? I think we're talking about it. He just wants to make it clear that what you were talking about was nuclear fission.
Yes. So it's nuclear fission, and we also fission and fusion. Right now, we are primarily a fusion world because we haven't really cracked the nut of how to get fission plants moving on a large scale. So fusion is currently what we're dealing with from a nuclear standpoint. But yes, that is what the discussion is.
Thank you. Our next question is, do you have suggestions for converting to a practical, reliable, affordable, carbon-free approach to heating existing buildings in the northern part of U.S.?
Wow. So yes, it depends on a couple of things. One, it depends on scale. And so if we talk about if there's a fair amount of land around, and I mentioned in my first example, the use of geothermal heat pumps. That is a super efficient, not necessarily always considered sustainable, but it's a super efficient method to heat and cool, even in the northern climates. The ground stays a constant temperature below the frost line, so you always have the ability to grab heat and dissipate heat from the building. So that's one source. But I'd be more than happy to talk about your particular case with you. But there are a lot of options. If you're not in an urban environment, you could really distinguish things like wind, solar. They have some advantages from strictly a building standpoint. But you have to look at this holistically. You've got to look at how the buildings are holding up. How are they performing? If you have, poor windows or low insulation, that's all things that have to be addressed as well. So when I talk about this holistically, I know we spend a lot of time talking about energy, mainly because that's where it all starts. But I think it's really important to look at each condition differently because they are different.
Okay, thank you. Our next question is, how do we plan for deferred maintenance given the high maintenance costs of sustainable buildings?
Yeah, so that's a good question. I think one of the things you have to really consider is maintenance costs don't have to be high when you're sustainable. I'm going to give you an example. Many universities over the years have used, you want to have your floors look waxed. So whether it's K through 12 or even on a higher ed, from a higher ed standpoint, oftentimes we'll see products like VCT in the past. And we would spend a lot of money buffing and stripping and waxing those floors every 6 months. So from an embodied energy standpoint, that floor was actually the most expensive floor we could put down. So from a maintenance standpoint, you're increasing your budget because you have a very particular thought in mind on how that works. So some choices to make is, and I've led clients through, if we have a lower budget, let's look at a rubber floor that doesn't require any maintenance. You use a neutral cleaner on it, twice a year, and clean it up, and you're good. Yeah, and there's lots of options there. Or do you go, if your budget's a little higher, you look at something like a porcelain tile that has a 30 or 40-year lifespan, with expectations that there could be some crackage or breakage because of accidents and things like that. So I really think the use of sustainable materials doesn't necessarily require more maintenance costs. It's, again, those decisions and making smart decisions on how we use materials. I hope that gave you enough information on that.
Thank you. Our next question is, can you give some examples of greenwashing that people should be aware of?
Sure. There's lots of it. So, and my apologies if anyone in the room has one of these, but a couple of the things I've talked about over the years is Tesla. Now, as Billy mentioned at the beginning, I designed Tesla's solar manufacturing facility. They do two things, and they're really trying to bring down the environmental footprint and the environmental impact of these products. But both solar panels and electric cars have a higher embodied energy from manufacture to end of life than anything else. So if we look at and we compare an electric car and a gas-powered vehicle, the embodied energy to make the electric car is about 20 times higher than it is to make the internal combustion engine vehicle. That means you can drive you have to drive an electric car, and I know those people that have a Tesla love their Teslas. You're going to have to drive that car for 20 years before you make up for the fact that your neighbor may have bought a Jeep Wrangler and is driving that down the street. So that's that education. We're being pushed in this from CAFE standards and government decisions. We're being pushed in this direction to buy electric vehicles. One of the problems with it is we don't have infrastructure, and the bigger problem is that we aren't being told what the whole embodied energy in that vehicle is. That's a perfect example of this kind of question.
Okay, thank you. Our next question is, with so many windows in the Mastery Center, how was bird collision included in your design?
So what many people don't realize, and I'll answer this way. How many of you have had birds running into your building on a regular basis? Really, what you have to worry about with birds, especially in an urban environment, is that they start to perch or make nests on your building. And the client made the decision that wasn't a huge concern of theirs because they didn't have large avian species in the area. But really what happens, and very quickly, is that the avian species learn not to run into it, just like we do. So bird strikes into the building are very infrequent and aren't large problems. The glass on the building had a tint to it. So during the day, and you saw a nighttime picture with interior lights on, during the day, birds don't see that as clear. It has a tint, so they see the reflection as they fly towards it. And that's really one of those easy things to help mitigate that.
Okay, thank you. Our next question is, should we do budget planning first and then work within budget, or should sustainability be considered during budget planning to get more funding on the matter?
Well, that's a great question. Really, I think it's dependent on how you want to approach it. I think you should plan a project as your desire is. If you really want to have a sustainable building, then we should plan it from the beginning as sustainable. And all of that should be taken into consideration from a budgetary standpoint. We can, there's been lots of studies that have said, a sustainable project is anywhere between 1 and 10% more expensive. I have found that it's usually between 1 and 5%, and that has strictly to do with a number of the decisions that you made. The two projects I showed, they were both budgeted based on their sustainable decisions. So we went into it with, we want a sustainable building here. This is what we want to achieve, and establish the budget from that standpoint. And that takes some understanding from the beginning and some decisions at the beginning of the project that are fairly easy then to move forward with.
Okay, our next question is, what tools do you recommend for assessing climate as an asset for achieving net zero energy, water, and emissions?
So I suppose the answer to that is it depends on where you're approaching it. Tools from an energy modeling standpoint, there are a lot of energy modeling software that are out there. Many of them are integrated directly into our design software as we move forward. So that's always the best place, because we can make decisions based on, hey, we want to get to net zero. Okay, and I've worked on a number of net zero projects over the years. And I think one of the things that is always challenging is that balance, right? So we have to understand that by making a decision on a more efficient mechanical system, you have to make decisions on envelope, on electricity, and then how much power you need to generate. So really, currently, as we look at net zero, in today's industry, we're relying on solar, and we're creating a building that is all electric. And that's easy to do, but it can be complicated from an overall standpoint. So it has to be integrated in the overall design project. And as with making sustainable decisions for a building, if we want to start a net zero project, we have to know that from the beginning, because once we're down that path, it's a lot more problematic to change it.
Okay, thank you. Our next question is, most buildings on my campus are legacy. How do you plan and design sustainability for legacy buildings?
Yeah, sure. That's a great question. So I think really you have to look at it differently, right? Take an inventory of what the building is. And this is where the master planning aspect of a campus comes into play. We start looking at, okay, what can we do to improve the existing building? If you've got legacy buildings that are there for very important reasons, they are the fabric of your campus. You can't just go start tearing them all down and replacing them. First of all, the cost is astronomical to do so. Secondly, and perhaps more importantly, at least in this particular discussion, the environmental impact of knocking down a campus and then rebuilding it is just catastrophic to the overall fabric. So really what we do is we look at it individually. You know, do we, for example, 40% of all energy is lost through the roof. Well, do we increase our roof membrane and insulation to give us a better overall system? We have to look at the structural system and see how it's holding up, and can it hold more load? And if it can, then do we look at making improvements to the envelope? Do we improve the mechanical systems? All of that can happen, but we have to look at it holistically. We have to look at all of these parts and pieces and see how they interact with one another. You can't just say, okay, I'm going to replace the mechanical system because it's 20 years old and I'm going to put one in that's more efficient, because that more efficient system, the building envelope may not be able to really take advantage of what we have. You can look at things like replacing windows. High performance windows can do a number of things when installed correctly to help improve the overall envelope and environment within the building. And then there's all the materiality discussions that we can have, whether it's new paints that are better reflective, better flooring that's less maintenance, ceilings that reflect light better, improved lighting throughout the space. If you have legacy buildings, more than likely they're fluorescent technology. Well, one easy way to address that is to move to LEDs, and how we can better integrate that into the overall space. So there are lots of different things that we can do in an existing building, and oftentimes those are the best challenges and the best end results, because people see the building that they were in 10 years ago. It still looks similar, but it is much more sustainable to the environment.
Okay, thank you. We have time for a couple more questions, and if we don't get to all of your questions, Bill will be reaching out to you to answer them. Okay, our next question is, would small thorium-based nuclear reactors be a step in the right direction?
That's a great question. I think really we have to look at it from an impact standpoint. To answer your question, yes, I think it would. Any diversity in our energy usage and our energy production is a positive thing. And as I mentioned earlier, nuclear fission, 28 states are using it to power their states and provide electricity to the grid. We look at power generation, and that's an important thing, but especially in the Northeast, and then as we see in the Southwest, where we have a lot of seasonal issues with electricity, we have to look at infrastructure too. So we can't just go and tack on a bunch of power plants and then expect we're all going to be okay, because the infrastructure and the grid can't necessarily handle it all. So any movement away from current thought process, and that includes things like scrubbers in the stacks for coal power plants. We have an abundance of coal in this country, and we've gotten away from using it because it's dirty. Well, we have technology now that can clean that up and use a natural resource that we have for other purposes. So I think using any source of power is an important one, as long as we do it responsibly.
Okay, thank you. Okay, our next question is, with ground source heat pump, is it important to check radon levels in the test bore hole? This energy source has a fantastic potential, just want to avoid problems later.
Yeah, so one of the things that we've always done is I will use a closed loop system. So obviously testing for radon or any hazardous ground source environments, we always do a test well to make sure we can get the heat recovery and heat rejection that we need. But you're really drilling down into bedrock to manage this. And so as long as you have a closed loop system and you're not a vertical system, the horizontal systems that you oftentimes see let's say at the bottom of a lake or something like that, are a little different. But yes, always more information is always better than less. And to check for radon isn't that problematic. It's also not a huge question or huge issue because this system is isolated from the rest. So we don't have the concern of releasing radon into the building because it has no way to get in the building.
Okay, thank you. We have time for maybe one more question. Are there any studies that compare current life cycle for renewable energy sources versus legacy energy sources? For example, wind generation versus coal plants.
Sure. Yeah, there are a number of them. And actually, I always like to go back to one source, one primary source for all of my energy usage, and that's the U.S. Department of Energy. Whether they let us know or not, there is a wealth of information on their website that explains everything. They have data on every source of energy, how it's used, how much it produces, what its value is, and what problems it has. And I encourage clients when they're making decisions to look in that direction and look in their local, municipalities and how are they producing energy. Many states produce a lot more renewable energy than we think. And they downplay nuclear sources, they upplay, renewable sources because it's what we all believe at this point. So I always go back to that as a source of information, as the government's responsible for producing it. They just don't tell us that.
Okay, it looks like we have time for one more. Glass appeared to be the dominant envelope material in the example projects you highlighted. At what window wall ratio does your savings from daylighting get offset by your loss of energy through glass?
Well, so that's a great question, but I want to make one thing clear. The first example that I showed, the Masry Center, is a LEED Gold it's a LEED Gold project, and it obtained at the time 21 optimized energy points. So it was over 60% more efficient than the normal baseline building. So while there's a lot of glass in that envelope, especially on the side that I showed, we didn't lose energy efficiency because of it. So it's intelligent use of glass and how you use it that pushes that envelope. Glass to wall ratio, we can have that discussion, and it really becomes one of, if you're above 50%, you have to do a lot more to keep your envelope well enclosed. I mean, keep in mind, the best we can do right now is about an R10 for glazing, and that's some expensive glass, as opposed to, minimum is R20 for an exterior wall. And in many cases, we're well above that in some of our designs. So, I've seen walls that we've done that are R30 an inch or R30 for their overall exterior envelope. And roofs are well above that depending on the environment. So, I think it's dependent on each building. The two that you saw, yes, I agree completely. They're highly glass, preliminary from a glass standpoint, but they're also well insulated in other areas and in other ways.
Okay, well, that concludes the time we have for today. So, Bill, I'd like to thank you for a great, fantastic. You're getting some good kudos here through the chat box, and we have about a dozen questions that you'll need to follow up with the person asking the question. So, as always, thank you so much. And as a reminder, this is our last webinar for 2022. We'll pick up again in mid-February 2023. But if you'd like continuing education credits, please check out the website for any archived webinar. You can watch it and submit the form and get credits for it. So thank you again, Bill. And to our attendees, as always, thank you for taking time out of your busy schedule to be with us. So until we meet again, I wish you all happy holidays and have a great rest of the week. Thank you so much.
Thank you all.
Bye-bye.
Take care.